2.2, more on functions and their graphs. Use the graph to determine open intervals on which the function is increasing, decreasing, and constant if any. All right, cool. Let's try it. So this first one right here, we're going to focus on it. Let's see where it's increasing. Okay, so from negative infinity, which is way over here, right? Just keeps going over here to the left forever. So negative infinity, but you never reach infinity, so I put a parenthesis next to it. It keeps going up all the way up until negative 4. So all the way up to negative 4. Okay. Now, from negative 4 all the way over to negative 3, it's not increasing, it's not constant, but it's decreasing. So all the way from negative 4 to negative 3, it looks like it is decreasing. Then from negative 3 all the way up to negative 2, negative 2 is right here, it looks like it's increasing. And then from negative 2 all the way to positive infinity, it looks like, right, just keeps going. It's going to keep going to the right forever. So that from there on, it's going to be decreasing. And it doesn't look like there's any point at which it's really constant. So let's try the next one. Okay, so negative infinity is right over here to the left. So that's negative infinity. And then all the way up to this point right here, right? So that's a negative 4. It looks like it's just flat. So that is a constant. So we have negative infinity all the way up till negative 4, in which it is constant. Okay. Now, and then from that point, negative 4, all the way up into this point over here, positive 2, it looks like it is increasing. So we would go from a negative 4 all the way up to a positive 2, and we would say that's increasing from there to there. And then we would say even from 2 all the way up to 4, it's also increasing. Now, there's really no reason to break that up, right? Because negative 4 all the way to 2, it's increasing, but from 2 to 4, it's still increasing. It's not increasing at the same rate. It does not have the same slope, but it's been increasing the entire time. So it would be better if we just wrote it as that it was increasing the entire time. Okay, now from 4 all the way, looks like to 5 and beyond, right? Because this keeps going to positive infinity over there to the right. It looks like it's constant again. Okay, so constant. So we go from a 4 all the way to a positive infinity. It looks like it is constant. Use the graph to find each of the following, at which f has a relative maximum. Okay, now, since this goes off to infinity from there, that doesn't count, and this goes off to infinity there, that doesn't count. But in between, say for instance, negative 2 and 0, there is a relative maximum at this point right there. Okay? So what we would say is, at which f has a relative maximum. Okay, so it looks like the maximum is right here. So the at which f would be negative 1. What are the relative maximum? Okay, so what is the relative maximum? Well, the relative maximum looks like it is 3. At which f has a relative minimum. Well, it looks like there's a minimum here, and there's a minimum here. At which f? Okay, well, it looks like there is at negative 2 and 0. Okay, what are these relative minima? Okay, these relative minimum looks like they are at negative 1.